Hello my dear students, welcome to Maths YouTube channel Maths Insights. I am your Maths teacher Siva. Today's topic is very important, orthogonal matrix. This is very important definition in matrices. Orthogonal matrix means a square matrix. That should be a square matrix before checking whether it is orthogonal or not. If a square matrix A is said to be orthogonal, it has to satisfy the condition that if you do the product of the matrix A and its transpose, that means A into A dash is equals to I, where I is called identity matrix and A dash is its transpose, then your matrix A is said to be orthogonal matrix. There are very important properties for this. The first property says that the first property says that if A is orthogonal, then the condition is A inverse is equals to A transpose. How it will be? See, if you take the condition, what is the condition to be orthogonal? A into A dash is equals to I. Your matrix A is multiplying with another matrix and your result is identity matrix. Then whatever the matrix comes here, that is called inverse of the matrix A. In algebra also, if you multiply any number with another number and your result is 1, here you have to get 1 by 2, you have to multiply 2 with 1 by 2 to get 1. This 1 by 2 is called multiplicative inverse. Similarly, like 1 in algebra, this identity matrix is also an identity element under multiplication. You are multiplying A with another matrix, let it is transpose, you are getting identity matrix. This matrix is called transpose, this matrix is called inverse. Inverse is written as A inverse. Therefore, A inverse is equals to A dash. Then A is orthogonal. Otherwise, if A is orthogonal, then A inverse is equals to A dash. Sometimes you may face a question that if A inverse is equals to A dash, then the type of matrix is called. You may not get this direct definition. So keep in your mind, if A inverse is equals to A dash, then that is said to be orthogonal matrix. Property number 2 says, if A and B are orthogonal, then A into B is also orthogonal matrix. Very simple. You have taken two square matrices A and B, and which are orthogonal means A into A dash is equals to I and B into B dash is equals to I. You have to prove that AB is also orthogonal. Very simple. If you want to prove AB is orthogonal, you have to multiply that matrix with its transpose. AB into its transpose means AB whole dash. That is equals to AB into, you know that AB whole dash is equals to B dash into A dash. You can write it as A into B dash into A dash. But you know B into B dash is equals to I, since B is orthogonal. Therefore, that is A into I into A dash. If you multiply any matrix with identity matrix, your result is same. That means this is A into A dash. Since A is orthogonal, again A into A dash can be written as I. Therefore, the result of this AB into AB dash is equals to I. Therefore, this matrix AB is also orthogonal matrix. Third property important. If A is orthogonal, then A inverse and A transpose will also become orthogonal. Very simple. If A is orthogonal means they are giving the condition that A into A dash is equals to I. They are saying that this is true. So if you want to prove this A inverse is also orthogonal, you have to do multiplication of A inverse with A inverse whole dash. You have to multiply a matrix with its transpose, and if you get identity matrix, then that is said to be orthogonal. I am verifying it. You can write this is A inverse into, this can be written as A dash whole inverse. Now this can be written as A dash into A inverse. See, A dash, this can be written as A dash into A whole inverse. If you remember AB whole inverse, that is equals to B inverse into A inverse. You have to write in reverse order. So A dash is coming in the second place, I am writing in the first place. A inverse in the that means this, if you want to write this inverse to both of them at a time, you have to change the order. A dash and A whole inverse. This A dash into A, otherwise A into A dash, both are equals to I. Therefore I whole inverse, that means inverse of identity matrix will give you again identity matrix. Therefore this A inverse is also said to be orthogonal matrix. Very simple. If you want to prove any matrix whether it is orthogonal or not, multiply that matrix with its transpose and your result should be identity matrix. I am doing the same thing. And also final one, A dash. You have to prove A dash is orthogonal or not. They are clearly saying that. So I want to multiply A dash with its transpose. My answer should be identity matrix. I am erasing this. Okay, that is equals to A dash into, A dash whole dash is equals to A again. So since A is orthogonal matrix, A into A dash or A dash into A, both are equal. Therefore that is equals to identity matrix. Again you are getting identity matrix if you are multiplying with A dash with its transpose. Therefore A dash is also orthogonal matrix. Very important. Students are by-hearting these properties without understanding. So I clearly explained with examples so you can understand in a better manner. This is today's video. Please do subscribe if you like this video, share it and like it. We will meet again in the next video. Until then, have a nice day. Thank you.